Hey, welcome back. It's Back to the Basics. I'm Sean Barr, and at LookingPoint, we help IT organizations make decisions around collaboration, networking, and security. And today, we're going to be talking about how the internet works. Let's go! Hey, we're back, and we're going to be drawing up a high-level overview of how the internet works. We're going to take you through the process of how you connect to a website. All right, so first thing I'm going to do is draw up an overall architecture, and then we're going to take it from there. So we've drawn up our high-level internet diagram. But essentially, before we get into talking about how the internet works, let's talk a little bit about what are the components that make up the internet. So the internet is made up of mostly routers and switches, and also long-haul connections. That could be fiber, or that could even be copper in some cases. But essentially, those service providers are connecting together routers and switches, and they form a mesh, and that is what we consider the internet. Now we're going to talk about how a host connects to a website. So if you were going to yahoo.com, google.com, pick the site. We're going to use www.xyz.com. Pick the site, doesn't really matter. It's all going to fundamentally work the same. So essentially, if I'm on my host down here and I go to www.xyz.com, the first thing that this host is going to do is make a DNS request. And that DNS request is going to go to the DNS server configured on this host. And that DNS server is over here, and it's going to say, hey, what is the IP address for www.xyz.com? It's going to ask that question. And the DNS server is going to respond back with an IP address. And in this case, we're going to say it's 1.1.1.1 for the example's sake. Now this host knows that www.xyz.com, the IP address is 1.1.1.1. And so it's going to take that IP address and it's going to compare it over to its IP address, which is the 192.168.1.0 and the subnet mask. And it's going to say, hey, is this IP address on my network? And the answer is no. So what it's going to do then is go to its default gateway. So every host has a default gateway that's accessing the internet, and it will go, hey, I got to send a packet now to 1.1.1, and my source address is 192.168.1.0. So in order for that to happen, it's going to have the MAC address of its upstream router, and it's going to build a packet with the source IP of itself, which is, I'm just going to write 1.10 for simplicity. And it's going to have the destination IP, and I'll write it out in complete terms here, 1.1.1.1. So that's the destination IP. It's also going to have the source MAC of the host, which I'm just going to write host, and the destination MAC of the gateway. So in the packet, the source IP is the host, the destination IP is the gateway, the source MAC is the host, the destination MAC is the gateway. Now, the MAC addresses happen at layer 2, and the IP addresses function at layer 3. And as soon as that packet reaches this router, it's going to look in its routing table and make a decision. Is 1.1.1, where is that connected? It's going to make a decision to use its egress interface. And it's going to send the traffic in this direction. So when the packet reaches this gateway, it's going to do two things. The first is it's going to NAT the IP address. The reason why is this is an RFC 1918 address. It is only for internal usage, and it doesn't get routed through the internet. And so it's going to NAT it to a public-facing IP address. So it's going to get NATed at the router, and then it's going to route that packet up to its upstream gateway. And what it's going to do is it's going to change the source IP address now from the 1.10 to a publicly routable address, and I'm just going to say 64.5.6.7. It's going to translate it to that. The second thing it's going to do is look at its destination MAC address, and it's going to strip these. It's going to strip these from the packet, and it's going to add routers, the gateways, as the source, and it's going to add the internet gateway up here, and I'll just say IG, as the destination MAC. So it strips the layer 2 information, it adds its own source MAC, and puts the destination MAC at the internet edge. Now, one thing that happens at each hop is it's going to make routing decisions at layer 3, these IP addresses, but actually route the traffic using layer 2, so based on MAC address. So it's going to be stripping the MAC addresses and appending its own, and appending the destination MAC. So the same thing happens here from this leg to this leg. Essentially what it's going to do is leave the source IP address and the destination IP address the same. However, this gateway is going to strip the source and destination MAC, and I'm just going to call this A and B, and it's going to say the source MAC is internet A and the destination MAC is internet B. But the IP addresses are going to stay this translated IP address and the destination IP address of 1.1.1. And through each of these hops, if we have C here, the same thing is going to happen. A is going to get stripped, B is going to get stripped. It's going to go IB to IC. And so essentially, as we go hop by hop, we're stripping MAC addresses or layer 2 information, reappending it, but the layer 3 information stays the same all the way until it reaches the host, which is 1.1.1.1. And as soon as it reaches the host, TCP is a two-way conversation. The host is going to actually go back and respond all the way down to the host. It's going to hit this gateway, it's going to get translated back to its original address, and there you have it. That's internet connectivity in a nutshell. If I said anything in this video that you're like, hey, I'd love to know more about that, leave a comment, make sure you like and subscribe, and we will see you on the next Back to the Basics. Thanks for watching.